Let's make sure we understand the small example, then the generalized version will be a lot better. So I'm going to go through this quadratic graph. Could you help me put in the x and y intercepts as coordinates, and we will carry on from there. So x-intercept is at 1, 0. Your y-intercept is at the value 0, 1. I'm going to do replacements. And when we do replacements, we are going to replace your y or your x. So first, let's replace the y into a y minus 2, and let's check for what happens. If I change it to y minus 2, then this equation becomes y minus 2 is x minus 1 squared. And your y becomes x minus 1 squared plus 2 if I move the 2 around. Now, what happens to a graph when we add the value 2 to one side? It means you are having your y values all shifted up by 2 units when you add 2. So let's think of this as, I just write on the left-hand column, we're going to shift up by 2 units. And we are shifting up because it's the y value that increases by 2 on the right-hand side. Let's draw in the graph together on the right. We will draw in that quadratic graph, and that lowest point is also shifted up. So that lowest point is now at 1, 2. Your y-intercept coordinate also changes, it's 0, 3 respectively. Now there is a name for shifting the graph. We call this a translation. We translate the graph. And you note also on the sign. Now, when we do replacement, it was negative, but we didn't move the graph in the negative direction. We actually moved it up in the positive direction by 2. So the direction that you move is always opposite to the sign that you replace by. Okay, so let me just write by the sign, opposite sign to your replacement. If your replacement was negative, the actual transformation or the movement is a positive movement. It's going up by 2 units, not by minus 2 units. Okay, note this opposite thing, because throughout today, we are going to have something like that, opposite sign. Second one, let's replace it to half y. So from the initial equation, we write it as half y is x minus 1 squared. So again, let's make y the subject, and we try to observe the equation. What should happen if it's a times 2 in front? That means all your y values, you're going to multiply by 2. So let's write that observation on the left again. We are going to multiply 2 to all your y values. Multiply 2 to all the y values. Get the graph drawn out again on that right-hand side. We take reference from the original graph at that top. We multiply 2 to all the y values. So you think of it as you are stretching your graph top and bottom. Stretch the graph up and down. We think through the coordinate. We are multiplying 2 to the y. So if it's 0, it's still 0. Your x should be unchanged. You are multiplying 2 to the y only. Your vertical intercept will now be changed to 0, 2 also, times 2 to all the y. So what is this called in our syllabus? I said just now was translation, that's moving. If you are stretching the graph, the word that we will use is the word scale, or on rare occasions, you will see your question says you stretch. Both refers to the same thing. But let's make the important observation. When I replaced, it was with half. But the actual movement, was it multiplying by half? It wasn't. It was multiplying by 2. So now this number at the coefficient and the multiplication that you eventually do is seen as it is the reciprocal to your replacement. If you are replacing with half, the actual movement is the reciprocal. You multiply by 2. Okay, so note the first one was opposite sign. This one is reciprocal. And last equation, I want to replace to minus y to the original equation. So minus y is your x minus 1 squared. Let's make y the subject. You will have a negative sign in front. Now, based on our knowledge of graphs, what will happen if there is a negative sign in front of the equation? It will mean that whatever you have that is positive y value will now become negative y value and vice versa. So this is now a reflection. Those on top will go down, those below will go up. It is a reflection. Let's draw in the graph on the right-hand side to understand that reflection. So those on top will all go down. The initial quadratic graph was lying above the x-axis. They are now all lying below the x-axis. That x-intercept stays is at 1, 0. The y-intercept is 0 minus 1 now. It's reflected downwards. Which axis did we reflect across? When we talk about reflection, we will say it's about which axis? From top to bottom, so we were reflecting across your x-axis. So be very careful here on the observation of replacement versus the actual movement. You were replacing y, but you did not reflect the y-axis. You reflect the opposite variable axis. Okay, the actual movement in the reflection of the axis is always the opposite variable. If it's y, the movement is x-axis. Now, let me do a very quick summary. What is important here is we are going to learn these 3 things today: translation, scaling, reflection. Each of these, we call it a transformation. Every transformation is linked to one type of replacement. So every replacement, we must know what is the actual transformation. Replacement, transformation, replacement, transformation. There are only 3 types. Every transformation, make sure you know the replacement, if it's minus 2, the movement is plus 2. If it's half, the movement is times 2, reciprocal. If it's y replacement, it's x-axis reflection, opposite variable. Okay, this is an example for you to appreciate what's going to happen. But now we go to the next page where it's a summary table of the 3 types of things that we want to do. We want to learn now how to write out the description